Today's the first lesson of Unit 2. Unit 2 is a continuation of functions, so we're still looking at different functions and what we can do with them. So Lesson 1 is on operations, and there's 4 operations we're going to go through. We're going to talk about the sum, which is addition, difference or subtraction, product, which is multiplication, and the quotient, which is division. All right, if you're working with 2 different functions, let's label our functions f and g, just for the purpose of explaining. If you're working with 2 different functions and you are adding them together, that's what the sum is, so addition, then the function is defined by f plus g of x, or f of x plus g of x. This literally means if you are adding 2 functions, you add like terms. If you have a fraction, make sure you create a common denominator. Other than that, you just add what's similar. Do not try to add something that is not similar. Next, we have the difference of functions, which means subtraction. We're using f and g to explain this. And the difference of functions f and g is defined by f minus g of x, or f of x minus g of x. Next is the product. Product is multiplication. The product of f and g is defined by f times g of x, or f of x times g of x. Lastly, we're going to look at the quotient of 2 functions. Quotient means division. The quotient of f divided by g is defined by f over g of x, or f of x over g of x. And just remember that when you have a fraction, you cannot have a 0 in the denominator. That does apply to this. So we cannot have a number such as 4 over 0. So I'm just going to make a quick note that the denominator cannot equal 0 for a function like this. For the first example set, we're going to use these 2 functions. We have f of x that's equal to 1 over x plus 2, and we have g of x that's equal to x over x plus 1. We're going to go through each of the 4 operations, starting with addition. We have f plus g of x, which is the same thing as saying f of x plus g of x. We know that f of x is equal to 1 over x plus 2, and we know g of x is equal to x over x minus 1. All right, in order to add these 2 functions together, we're going to have a common denominator. We need the common denominator to include both of these values. These values don't have anything in common, so we're going to multiply each one by the other. Make sure when you're multiplying for a common denominator, you multiply both the numerator and the denominator. So for example, this first expression of 1 over x plus 2 needs to receive the denominator of x minus 1. So we're going to multiply the numerator by x minus 1, and we're going to multiply the denominator by x minus 1. The second fraction of x over x minus 1 needs to receive the denominator of x plus 2. That means I'm going to multiply the numerator by x plus 2 and the denominator by x plus 2. When I simplify my first function, we have 1 times x minus 1. 1 times x minus 1 is just x minus 1 over our denominator of x plus 2 times x plus 1, x minus 1, sorry. Those are both expressions. I'm going to leave those as expressions. So I'm going to write this as x plus 2 times x minus 1. In other words, I'm leaving them in factored form. My second expression has a numerator that needs to be distributed. We're going to distribute this value of x to both terms in the parentheses. That gives me a numerator of x squared plus 2x. And our denominator, we're going to leave the same as the first denominator, the one I did right here. We're going to leave it in factored form, and I'm going to write it as x plus 2 times x minus 1. Now just a quick note off to the side. These functions both have a numerator that's in standard form and a denominator that's in factored form. I would recommend leaving it like this. You're going to have to add the numerator together and then factor it, if possible, canceling any common terms. So leave your numerator in standard form, leave your denominator in factored form until the last step. Now that we have both of our fractions with the same denominator of x plus 2 times x minus 1, I can add these expressions together. And when you add fractions, you only add the numerator. My numerator becomes x minus 1 plus x squared plus 2x. And my denominator remains the same. That's why we found a common denominator. So it's x plus 2 times x minus 1. Now, if possible, combine any like terms in your numerator. The only like terms we have are x and 2x. When I write this in standard form, I'm going to write it as x squared plus 3x minus 1 divided by x plus 2 times x minus 1. And now you have to think to yourself, can I factor this numerator? So are there two factors that multiply to equal -1 and the same two factors that add to equal 3? And the answer to that would be no. This cannot be factored. So we can leave that in standard form, giving us this as our final answer. If by chance you could factor that numerator, then you need to do that and you need to cancel any common terms you have. The directions also state to find the domain. So we're looking for the domain of this fraction that we just simplified. We learned domain in the last unit. This is a fraction right here, so you have to find the domain of the fraction, meaning you have to find what creates a 0 in the denominator, and you need to get rid of that value. Hopefully you can just see quickly on this function that you cannot have a -2 in the denominator, and you cannot have a +1 in the denominator. Those two values would make each of these terms equal 0, which we do not want, so we have to get rid of them. So for your final answer, when you're writing domain on this function, we're going to say that the domain is from -∞ to -2, from -2 to +1, and then from 1 to +∞. Also, just a quick note, you always find the domain before you simplify. In this case, we didn't have to simplify, so that is our final answer. Next, we're looking at subtraction, or finding the difference between two values. This is the same thing as saying f of x minus g of x. All right, for our two functions, we're using the functions above, our f of x function and our g of x function. F of x is 1 over x plus 2. G of x is x over x minus 1. Right here we have to create a common denominator, but we actually already did that in the first example. So we can just pull our common denominator from the first example and work from there. So now that we just grabbed our information from the first example, be very careful and make sure you note that this time we are subtracting. We are not adding again. We are subtracting these two functions. And when you subtract, you have to subtract all terms in the second set of parentheses, or in this case, the second fraction. When I subtract my numerators and leave my denominators, I'm going to end up with the expression of x minus 1 minus x squared minus 2x. And again, just do not forget that this subtraction sign gets applied to both of the terms in the second set of parentheses. All right, our denominator is the same, x plus 2 times x minus 1. At this point, we're going to combine any like terms. The only like terms we have would be x and negative 2x, leaving us with negative x squared minus x minus 1 all over x plus 2 times x minus 1. Now this is the point in the numerator where you need to check and see if you can factor it. If you can factor this, then you need to do that and see if you can simplify. The first step to factoring is to always make sure your numerator is going to have a positive leading coefficient, which this one does not. We have a negative sign. So I'm going to take out negative 1, leaving me with x squared plus x plus 1, all divided by x plus 2 times x minus 1. Now we have to think, are there any two terms that multiply to 1 but also add to 1? And there are no two terms that would fit that criteria, so we are going to say this is our final answer. The last step is to identify the domain, and the domain here is actually going to be the same as the first example. We do have the same denominator in both of these examples, therefore the domain is also the same. So our domain is from negative infinity to negative 2 to positive 1, and 1 to positive infinity. Up next is multiplication. When we multiply two functions together. When we do this, this is the same thing as saying f of x times g of x. f of x is 1 over x plus 2. G of x is x over x minus 1. When you're adding functions or subtracting functions, you have to create a common denominator. But in this example, we are multiplying functions, and you do not need a common denominator. All you do is multiply straight across. That means you are multiplying your numerators, multiply those together, and you are multiplying your denominators. When we do this, our numerator becomes x, and our denominator becomes x plus 2 times x minus 1. Now, if you could factor this and simplify it by eliminating common factors between the numerator and the denominator, you would have to do that. Here, you cannot. You are not going to have any common factors. That is your final answer. And once again, the domain is still the same as it was for number 1 because our denominator has not changed. So our domain is negative infinity to negative 2, negative 2 to positive 1, 1 to positive infinity. Our last example is number 4, which is using the quotient property. It's when we are dividing functions. F divided by g of x is the same thing as saying f of x divided by g of x. And when I write that out, we have 1 over x plus 2 divided by, x over x minus 1. When you are dividing fractions, you are multiplying by the reciprocal. Or in other words, flip the second fraction and multiply. When I do that, my numerator stays the same. It stays as 1 over x plus 2. And my denominator will flip, becoming x minus 1 over x. Make sure you indicate that you now have multiplication. Now that we have multiplication, you multiply straight across. You multiply your numerators, you multiply your denominators. Our numerator becomes x minus 1, and our denominator is x times x plus 2. Once again, for the last time, if you can factor, please do that. Eliminate common factors. In all 4 of these examples, you cannot factor, so that is your final answer. This one here does have a different denominator, and actually we're going to go right back to Algebra 2 on this one. When you multiply by the reciprocal, you actually have to include multiple different denominators. You have your original denominator of your first function. You're going to have your original denominator of the second function, and you have the new denominator of the second function. So you have to include all of those values for your domain. That means I can see right here that x cannot equal negative 2. Right here, I can see that x cannot equal positive 1. And here, x cannot equal 0. Okay, do not forget to include the original denominator of the second function. When I write out the domain, it's going to be negative infinity to negative 2, negative 2 to 0, 0 to 1, and then 1 to positive infinity. Super important to know that domain. If you have any questions on that, please let me know. Okay, I'm gonna go over the on your own section. I'm gonna do this without explaining anything, so you can either watch here and check my answers, or you can go to my answer key on my website and see the answers there.